Hello everyone. In this video, I will be talking about motion in 2D using vectors. In the last video, we had seen vectors. Now in this video, I will be using this vector for describing motion in 2 dimension or motion in a plane. Okay, now position vector and displacement. Consider a body moving along a path as shown in this figure. Then we can represent this motion of the body along the path along these two coordinate axes. Now the position vector of the body at P is given by xi plus yj when we resolve the vector along the coordinate axis. Now at P dash the position vector is x dash I plus y dash j. Then for the displacement vector delta r is equal to r dash minus r, which is the difference between the final position and the initial position. That is equal to delta r is equal to delta xi plus delta yj, where delta x is equal to x dash minus x and delta y is equal to y dash minus y. So we have used vectors to represent the motion of the body along this two-dimensional path. Now we can see velocity in the case of 2 dimensions. The average velocity is the ratio of the displacement and corresponding time interval. Here, the average velocity is given by delta r divided by delta t. We have already seen that the displacement vector delta r can be represented as delta x I cap plus delta y j cap by delta t. Then it becomes average velocity v is equal to vx I plus vy j, where vx is equal to delta x by delta t, while vy is equal to delta y by delta t. Now, the direction of velocity is same as that of delta r or displacement. That is, the direction of velocity at any point on the path of an object is tangential to the path of that point and is in the direction of motion. Now, instantaneous velocity. Instantaneous velocity is the velocity at any instant in the path. It is given by the limiting value of the average velocity as the time interval approaches 0. The formula is given by v is equal to limit delta t tends to 0 delta r by delta t, which is equivalent to dr by dt, which becomes v is equal to limit delta t tends to 0. Now substituting the value of delta r, we get delta x by delta t I cap plus delta y by delta t j cap, which becomes I cap limit delta t tends to 0 delta x by delta t plus j cap limit delta t tends to 0 delta y by delta t, which is v is equal to I cap dx by dt plus j cap dy by dt, which is vx I cap. Vx, which is the component of the velocity along the x-axis, and vy, the component of the velocity along the y-axis. Now, the magnitude of velocity is given by v is equal to root of vx square plus vy square, and the direction can be found out using the formula theta is equal to tan inverse of vy by vx. Now acceleration. In the case of acceleration also, we can see two components, that is in the x direction as well as in the y direction, just like in the case of velocity. The average acceleration of an object for a time interval moving in a x-y plane is the change in velocity divided by the time interval. That is A is equal to delta V by delta t. That is equal to delta Vxi plus delta Vyj by delta t, which is equal to delta Vx by delta t plus delta Vy by delta t. Two components of acceleration are Ax and Ay. Now, instantaneous acceleration. It is the limiting value of the average acceleration as the time interval approaches 0. That is, instantaneous acceleration is given by the formula limit delta t tends to 0 delta v by delta t. That is, acceleration is equal to I cap limit delta t tends to 0 delta vx by delta t plus j cap limit delta t tends to 0 delta vy by delta t. That is, acceleration is equal to dvx by dt plus dvy by dt. That is equal to axi plus ayi. Now, velocity and acceleration vectors may have any angle between 0 degree and 180 degree between them. Now, motion in plane with constant acceleration. We have already seen some equations of motion for this case, that is motion in a straight line with constant acceleration. Now we can see for motion in a plane with constant acceleration. In this case, there will be two components of motion, that is along the x axis and along the y axis. Now, motion in a plane can be treated as two separate simultaneous one-dimensional motions with constant acceleration along two perpendicular directions. Then the equations of motion becomes two components, that is Vx is equal to V0x plus axt, where V0 is the initial velocity and ax is the component of acceleration along x-axis. Similarly, the component of velocity along y-axis Vy is equal to V0y, which is the initial velocity along y-axis plus ayt. Similarly, x is equal to x0 plus v0xt plus half axt square and y is equal to y0 plus y0yt plus half ayt square. The concept of relative velocity, as we had seen in the case of one-dimensional motion, can be applied similarly in the case of motion in the plane also. Now this is the end of this video. In this video, I had discussed motion in two-dimensional and explained it using vectors. If you have got any doubt in any of the topics discussed in this video, please do comment in the section below this video. Thank you.